In section 7.5, we're looking at solving equations containing rational expressions, and we also want to solve equations containing rational expressions for a specified variable. We want to solve each equation and check each solution. It is very important to check your solutions when you're solving any equation. In some cases, especially with rational equations, you may end up with a solution that doesn't work when you check it. Those are called extraneous solutions. What we want to do is to find the LCD and multiply both sides of the equation by the LCD so that we get rid of any fractions, and then we can use our traditional methods for solving equations. So in example A, we have x over 3 minus x over 9 equals 8. We want to find the LCD. The LCD of each of those denominators is 9. So we multiply both sides of the original equation by 9, where the original equation is x over 3 minus x over 9 is equal to 8. So I'm going to multiply the left side of the equation by 9 and the right side of the equation by 9. When you do that, you can distribute the 9, and 9x divided by 3, that's going to give us 3x. 9x divided by 9 is going to be minus x. And on the right side, 9 times 8 is 72. Simplify the left side to get 2x is equal to 72. Divide both sides by 2 to get the solution of x is equal to 36. It's very important that we check our solution by plugging in our answer back into the original equation. X is 36, so the equation becomes 36 over 3 minus 36 over 9. We want to check to make sure that is equal to 8. And 36 over 3 is 12, and 36 over 9 is 4, so 12 minus 4 does equal 8. So we know that x equals 36 is the solution to that rational equation. We're going to do the same procedure for example B. 4x over 5 minus 8 equals x. The LCD is 5. So we're going to multiply both sides of the original equation by 5. Multiply the whole left side of the equation by 5 and the whole right side of the equation by 5. We are going to distribute the 5. And the 5 times 4x over 5, the 5's will divide out, so that gives us 4x, and 5 times this minus 8 is minus 40. And on the right side, x times 5 is 5x. Now we're going to solve this equation by subtracting 4x from both sides, and then we get negative 40 is equal to x, or x is equal to negative 40. We also want to check our answer by plugging in negative 40 back into the original equation to get 4 times negative 40 divided by 5 minus 8. Check to make sure that that is equal to negative 40. So let's simplify. We have 4 times negative 40 is negative 160 divided by 5 minus 8. And negative 160 divided by 5 is negative 32 minus 8. That does equal negative 40, so we know that the answer works. X equals negative 40 is the solution to that rational equation. For example D, we have x plus 10 in the numerator over x minus 5 equals 9 divided by the quantity 5 minus x. Let's rewrite this equation because x minus 5 is very similar to 5 minus x. So we can write the left side, keep it as x plus 10 over x minus 5, but the right side, this 5 minus x, I know that I could write 5 minus x as the opposite of x minus 5. So I can bring that opposite sign in the numerator so that I get a negative 9 in the numerator over x minus 5. Now the LCD is what I want to multiply both sides by to get rid of the fractions in the rational equation. So my LCD is x minus 5. I'm going to multiply both the left side and the right side of that equation by the LCD of x minus 5. Okay, so when you distribute here, the x minus 5s will divide out, so the left side of the equation becomes x plus 10. On the right side, when you distribute, the x minus 5s will divide out, so the right side will equal negative 9. Now we can solve this equation by subtracting 10 from both sides to get x equals negative 19. We always want to check our work by plugging in our answer back into the original equation. So we get negative 19 plus 10 divided by negative 19 minus 5 will equal 9 over 5 minus negative 19. We simplify this to check to get negative 9 over negative 24 on the left side and 9 over 24 on the right side. Since negative divided by negative is a positive, we know that both sides are equal. The equation is balanced, so we know that x equals negative 19 is a solution to that rational equation. For example E, let's simplify the denominators by factoring. We get 4 over x minus 4 plus 4. When we factor out the 2, it's 2 times the quantity x minus 4 equals 6. So our LCD, least common denominator, is 2 times the quantity x minus 4. We're going to multiply both sides of this equation by that LCD. We're going to multiply by 2 times the quantity x minus 4 on the left side and the right side. So when you distribute the LCD to both of those big fractions, the x minus 4s will divide out, so we get 2 times 4. And then distribute here, the 2 and the x minus 4 will divide out, so we get 4. And on the right side, 6 times 2 times x minus 4, that's going to be 12 times the quantity x minus 4. On the left side, we get 8 plus 4 is equal to the right side. Distributing the 12, you get 12x minus 48. We can add 48 to both sides. And 8 plus 4 plus 48 gives us 60 is equal to 12x. Divide both sides by 12 to get x is equal to 5. We want to check our answer, make sure that this is a solution to that rational equation by plugging in 5 into the original equation for x. We get 4 divided by 5 minus 4 plus 4 divided by 2 times 5 minus 8. We want to check to see if that is equal to 6. We get 4 divided by 1 plus 4 divided by 2 times 5 is 10 minus 8 is 2. That gives us 4 plus 2, which is equal to 6. That checks out. So we know that x equals 5 is a solution to that rational equation. To solve this equation, x divided by the quantity x minus 7 plus 6 equals 7 divided by the quantity x minus 7. We want to multiply both sides by the LCD. LCD is x minus 7. We're going to multiply the whole left side of the equation by x minus 7 and the whole right side of the equation by x minus 7. When you distribute the x minus 7 to the first term in the parentheses, the x minus 7s will cancel out to get x, or divide out, plus 6 times the quantity of x minus 7 on the left side. And on the right side, the x minus 7s will divide out, and we get 7. We can simplify this answer by distributing. We get x plus 6x minus 42 is equal to 7. Combining like terms, we get 7x minus 42 is equal to 7. Add 42 to both sides to get 7x is equal to 49. And then finally divide by 7 to get x is equal to 7. Again, it's really important that we check our solutions when we're solving any type of equations, especially rational equations, because there's a possibility that our solution may not work even though we've done everything algebraically correct in solving. So if we plug in 7 into the original equation for x, we get 7 over 7 minus 7 plus 6 equals 7 over 7 minus 7. Okay, now we have a problem here because when we simplify this, 7 divided by 0 plus 6 equals 7 divided by 0. The problem here is that we cannot divide by 0. Since you cannot divide by 0, if you try it on your calculator, you'll see that you end up with an error. So even though algebraically we get the answer x equals 7, we could say that x equals 7 is not a solution. We call that an extraneous solution. So in terms of solving this rational equation, we could say that there is no real solution. Let's solve example G by first factoring each of those denominators. We get negative 5x in the numerator. When we factor out the 3 from the denominator, we get 3 times the quantity x plus 1 equals 2x. Factoring out the 6 times the quantity x plus 1. And then the last fraction, 6x minus 4 in the numerator over x plus 1. Our LCD is what we want to multiply both sides by, is 6 times the quantity x plus 1. I'm going to multiply the whole left side by 6 times the quantity x plus 1, and the whole right side of the equation by 6 times the quantity x plus 1. When you distribute here, the x plus 1s will divide out, and 3 goes into 6 twice. So you're distributing a 2 to the numerator. And we end up with negative 10x on the left side of the equation. When we distribute on the right side, the 6 and the x plus 1 will divide out. So we're multiplying the 2x times 1, so 2x. And then when we distribute the 6 times x plus 1 to the second fraction on the right side, the x plus 1s will divide out, so we're going to be distributing the 6. So it's going to be plus 6 times the quantity 6x minus 4. Now we can simplify by distributing the 6 to get 2x plus 36x minus 24 on the right side equals negative 10x on the left side. We can simplify even further when we get negative 10x equals 38x minus 24. I'm going to add 10x to both sides of the equation, and I'm also going to add 24 to both sides of the equation, so that we get 24 is equal to 48x. And then by dividing both sides by 48, we get x is equal to 1/2. So let's, as always, we want to check any solution when we're solving equations by plugging the answer back into the original equation. To get negative 5 times 1/2 over 3 times 1/2 plus 3 equals 2 times 1/2 over 6 times 1/2 plus 6 plus 6 times 1/2 minus 4 over 1/2 plus 1. When we simplify, we get negative 5/2 divided by 3 times 1/2 plus 3 is 9/2 equals 1 over 9 plus negative 1 over 3/2. Simplifying the left side, we get negative 5 over 9 equals 1 over 9 minus 6 over 9, and it works out that the left side is equal to the right side. So our answer checks. X equals 1/2 is a solution to that rational equation. For example H, we are going to be multiplying both sides by the LCD. The LCD is going to be x times the quantity x minus 8. We're going to multiply the whole left side by x times the quantity x minus 8, and the whole right side by x times the quantity x minus 8. When you distribute to the first fraction, the x's will divide out, so we end up with 1 times the quantity x minus 8. And then when we distribute to the second fraction on the left side of the equation, the x minus 8s will divide out. So it's going to be plus 1 times x. When you distribute on the right side, the x minus 8s will divide out, and we will get x times the quantity x minus 7. Let's simplify this to get x minus 8 plus x on the left side, or 2x minus 8 on the left side, and on the right side we get x squared minus 7x. Now I'm going to, I notice that this is an x to the second power, so this is a quadratic equation. We want to solve it by setting it equal to 0. So we're going to subtract 2x from both sides, and I'm going to add 8 to both sides of the equation so that we can end up with a 0 on the left side and use the zero factor property to solve the quadratic equation. We get 0 equals x squared minus 9x plus 8. We can factor this. So 0 is equal to the factors of x minus 8 and x minus 1. We're going to set each factor equal to 0 using the zero factor property. So we get x minus 8 is equal to 0, or x minus 1 is equal to 0. Solve each of those equations. We can add 8 to both sides to get x equals 8 as a solution, and then we can add 1 to both sides to get x equals 1 as a solution. Okay. However, we do want to check our answer. We want to check both answers to make sure that we have not found any extraneous solutions, and this is very important when you're solving rational equations. Let's begin with checking x equals 8. When you check x equals 8, you get 1 over 8 plus 1 over 8 minus 8 equals 8 minus 7 over 8 minus 8. Now again, we have this problem. We have 1 over 8 plus 1 over 0 equals 1 over 0. You cannot divide by 0. So x equals 8 is not a solution. That is an extraneous solution. So let's check x equals 1 by plugging it into the original equation. We get 1 over 1 plus 1 over 1 minus 8 equals 1 minus 7 over 1 minus 8. So simplify, we get 1 plus 1 over a negative 7 is equal to a negative 6 over a negative 7. So this is 1 minus 1/7 equals 6 over 7. 6 over 7 does equal 6 over 7, so we do have a solution. X equals 1 is a solution, but x equals 8 is not a solution to that rational equation. Let's solve example I by factoring the denominators on the right side. So the left side is negative 2 over m plus 5 minus 3 over m minus 5 equals 15. Notice that this is a difference of two squares, so the factors are m plus 5 and m minus 5. Our LCD, least common denominator, is going to include all those factors of m plus 5 and m minus 5. We want to multiply both sides of the equation by that LCD, m plus 5, m minus 5, on the left and the right side. When we distribute here to the first fraction, the m plus 5 factors will divide out, so we end up with negative 2 times m minus 5 minus 3, and when you distribute the LCD to the second fraction, the m minus 5s will cancel out, so it's negative 3 times the quantity m plus 5. And on the right side, the m plus 5s and the m minus 5s will divide out, so that we only end up with 15 on the right side of the equation. So that, well, by multiplying both sides by the LCD, you eliminate all of those fractions, and then you can solve the equation using our traditional algebra techniques. If we distribute the negative 2, we get negative 2m plus 10 minus 3m minus 15 is equal to 15. By simplifying, we have negative 5m minus 5 is equal to 15. By adding 5 to both sides, we get negative 5m is equal to 20. And then by dividing both sides by negative 5, we get m equals negative 4. Okay, we do want to check our answer by plugging in negative 4 back into the original equation for x. We get negative 2 over negative 4 plus 5 minus 3 over negative 4 minus 5 equals 15 over negative 4 quantity squared minus 25. Simplifying this, we get negative 2 over 1, or just negative 2, minus 3 over negative 9, that minus a negative, is equal to 15 over 16 minus 25 is negative 9. So by getting a common denominator on the left side, negative 2 is the same thing as negative 18 over 9 plus 3 over 9 on the left side, and that is going to equal negative 15 over 9. So both sides check out. We know that m equals negative 4 is a solution to that rational equation. In these examples, we're solving each equation for the indicated variable. These are rational equations, so we do want to multiply both sides by the LCD. The LCD, for example, A, is A times B. We're going to multiply the original equation, 1 over A plus 1 over B equals C, multiplying both sides by the LCD of AB. When you distribute AB times 1 over A, the A's will divide out, so we get B. Distributing AB times 1 over B, the B's will divide out to get A is equal to A times B times C. Now we want to, since we're solving for B, we want any terms with B in it on one side of the equation, so we can subtract B from the left and the right side of the equation. But these are not like terms, so when we subtract B, we end up with A is equal to ABC minus B. Now we want to get the B by itself, so we need to factor the B, and when you factor out the B, you're left with AC minus 1. We want to get this B by itself, so we're going to divide both sides by AC minus 1. AC minus 1. So we end up with these two factors will divide out, and we get B by itself. So B is equal to A divided by AC minus 1. And that is our solution when we're solving this rational equation for the indicated variable B. In example B, we want to multiply by the LCD, which in this case is 2. We're going to multiply the whole left side of the equation by 2 and the whole right side of the equation by 2. When you multiply the left, you get 2 times A, and then here the 2 times the 1/2 is just going to be 1, so it's H times capital B plus lowercase b. Now we can distribute the H to get 2A equals BH plus lowercase bh. And here we want to solve for the capital B. So I want to isolate the capital B. We can do that by subtracting the lowercase bh from both sides. And that gives us 2a minus lowercase bh equals capital BH. And then we can get the b by itself by dividing both sides of this equation by h. We don't want to cross out anything here since it's next to a plus or minus sign, but we do simplify the right side so that we get b by itself equals 2 capital A minus lowercase bh all divided by h.